Hi everyone, very good evening to all of you. My name is Yash Dwivedi and today I'll be doing the analysis of weekly contest 147. So guys, please give me a +1 in the chat if everything is working fine right now, and then I will discuss. Bhavya, agree with you. Fourth solution for fourth question, my solution is also giving TLE. But I think n log n should have got accepted. I was using set, but for some reason it is not getting accepted. I also submitted in the same way. Okay, so yeah, guys, just give me a +1 and then I'll introduce myself and then we'll start. Okay, so yeah, my name is Yash Dwivedi. Currently, I'm working as a software development engineer at GeeksforGeeks. Besides this, I am candidate master on Code Forces and 5-star on CodeChef. And I have been teaching DSA and competitive programming at GeeksforGeeks for the past 2.5 years now. Try to contact and fix. Yeah, I will ask them that they should fix it because as far as I submitted it, I also thought that nlogin should have got accepted given the constraint. But it is not getting accepted for some reason. We'll see to it if any solution of nlogin gets accepted because I was also trying nlogin. So yeah, everyone can give me a +1 and then I'll start with the discussion for the contest. The other three problems, I guess the first three problems were quite easy. The fourth one was a good problem. Okay. So yes, guys, just hit the like button and then we are good to go. So let's open GFG Weekly Contest. Okay. And let's start coding this one. 24th March. Yeah. So let's view the details. Let's log in here. And let's all start solving the problems. Okay. So yeah, let us solve the problems now. Okay, everyone is ready. Could you discuss in reverse order? Yes, actually, I have done the last problem in. No, you are asking me to discuss in the reverse order for the. No, I cannot do that because many beginners also join. So that is why we have to start from the first problem only. But I will try to tell you my approach for the last problem completely. You don't need to worry about that. Okay. I think GFG make hard questions. I think first three questions were easy only. The last question was a bit tough uh, in terms of implementation. Okay, so yes, guys, please hit the like button and let's go ahead with the discussion now. Okay, so basically let us see this problem. Okay, it says that the problem name is equality. So let us discuss the first problem now. The problem name is basically equality. Okay, now in this particular problem they are saying that you're given two integers a and b. So an integer a will be given to you and another integer b will be given to you. What you have to do is you have to determine if it is possible to make a into b. So what you have to do is you have to convert a into b. Okay, you have to convert a into b, and what you have to do is, see, you will be given element a and you have to convert it into b. If it is possible, then you will return 1. So the first thing is, suppose that the integer that has been given to you, if a has been given to you and it is already equal to b, suppose a is already equal to b, then in that case what you can do, you will return 1, that yes, it can be converted. Okay, if a and b are same. Okay, because at the end of the day the problem says that you have to make a and b same. So if a is already equal to b, then you will directly return 1. Now otherwise there are two kind of operations. Okay, they are saying that suppose that a is odd. Okay, then what you can do, you can add 1 to a. Okay, if a is odd, then you can add 1. Okay, otherwise if suppose that a is even, then what you can do is you can add 2. Okay, if it is odd, then add 1 to it. If it is even, then add 2 to it. So basically what you are always doing is you are going to increase the value of a. Okay, you are only allowed to do which kind of operation? You are only allowed to do the increasing operation. Like, you are only allowed to increase the value of a. So suppose if the value of a is given as 30 and b is given as what? Suppose b was given as 26. So is it ever possible that I can make a value equal to b? No, because either I can add 1 to b, like either I can add 1 or I can add 2. So what I cannot do is I cannot subtract anything from a. So that is why when it will be impossible, if a value is greater than b, then it is never possible. So that is another thing that you need to consider, that if a value is greater than b, then you are not allowed to decrease a, because you can either increase the a value by 1 or by 2, depending whether it is odd or even, respectively. So that is why if the a value is greater than b, then you will directly return what? You will directly return 0. Okay, otherwise suppose that if a and b are same, then you will return 1. else if what other scenario is, suppose guys, you have to understand one thing, that whatever a value is there, if the a value is odd, then you add 1 to it, so you are making the value as even. Okay, if a is odd, then what you are doing, you are doing a plus 1, so it will become even after that. Okay, similarly, if a value is suppose even, then you are adding 2 to it, so it will become a plus 2, so again it will be even basically. So you can understand one thing, very clearly here guys, that a will always become even at the end of the day. So if b is odd, then you can never reach it. Why? Because suppose a value was suppose that a value was 26 and b value was, let's say, 27. So you can never reach from a to b, because you are always, a will always become even after the operation, because if a is odd, so you are doing plus 1, so it will become even. Okay, and if a is even, so you are doing plus 2, so it will always remain even. So that is why if the b value is odd, then it is not possible to reach the b value. So if b mod 2 equal 1, if it is odd, then in that case you will return 0. Okay, that it is not possible. Otherwise, you're going to return what, guys? You're going to return 1. I hope this makes sense, guys. Is this part clear? Please write yes or no. Yes, Priyanshu, login should have got accepted. I don't know why it didn't get accepted. Okay, so yes, let's submit this code and check. Yeah, you can see that my code is getting accepted. So is everyone clear with this first question? See, always you are allowed to add 1 plus 1 to a or plus 2. So if the a value is greater than b, then you cannot make a equal to b, because you cannot decrease anything in a. So that is why if a is greater than b, then it is not possible. If a and b are same, then yes, it is possible to make both same, because both are already same. Otherwise, see, if the a value is odd, then you are adding 1 to it. The moment you add 1 to it, so it becomes even. If the a value is 2, if the a value is even, then you are adding 2 to it. So then what happens? Then again it becomes even. So basically, ultimately a will keep on playing on the even values, right? A will get converted finally to even values. So that is why if the b value is odd, so you cannot reach any odd values, because the kind of changes that you're making to a, it will always keep a in even format. So that's why if the b value is greater, but if it is odd, then I will not be able to reach it. Is this clear? Please write clear in the chat, +1 in the chat, guys, and then we can think of proceeding further from here. So does this make sense to everyone? Please let me know, guys, and you can hit the like button if you're clear with this problem, and then I'll proceed further. Okay, so I'm just waiting for responses, and you can hit the like button to let me know if you're clear. I will just quickly paste this link here. Okay, so yeah, I'll try to submit my solution, submit my link in the chat. Okay, just let's generate it. Others can just let me know, and then we'll proceed further, guys. Okay. Yeah, so can we move ahead to the next question, guys? Please let me know. Can we move ahead to the next question? Okay, let's proceed further now. So let us move on to the second question for this contest, that was named as beautiful bits. It's a easy question only. Okay, so let's start with this question now, guys. It says that basically you are given q queries. Okay, understand one thing, that you are given what? You're given q queries. Okay, q queries are given to me, and what they are asking is that for every query from L to R. Okay, now first thing is, whenever need this guy in more weekly videos. Thanks a lot, Dip. Okay, so yeah, basically if you have got LNR, understand one thing, that if you have got LNR, which concept, like which algorithms or which data structure comes to your mind when you see the range L to R, whenever you are given range L to R. Okay, because when I started reading the problem, so I was given L and then R, L comma R range is given. So which data structure or which algorithms come to my mind, right? So either the prefix sum concept comes to my mind. Okay, I am just telling you, right? Prefix concept comes to my mind, or you can say segment tree comes to my mind. I'm just telling you so that you can understand that how to start thinking for a problem. Okay, understand this thing is very important. Or you can say that maybe Fenwick might come to your mind, right? Fenwick tree. Okay, or maybe sparse table or something like that might come to your mind. So advanced data structures, right? So this is very important, that when you start reading that L and R range is given, so prefix sum concept or segment tree or things like that should come to your mind. Is that clear to everyone? Please write yes in the chat. Is this part clear? Okay, Right, guys. Okay, so see, you are given what? You're given a range L to R here. Okay, you are given a range L to R, and they are saying that the range that has been given, you have to find the minimum X. Okay, find the minimum X for every L and R query that is given to you. Find the minimum X. Okay, for every L and R that is given to you, find the minimum X such that what? Such that the A of L ampersand and with X. Okay, uh, plus ARR of L plus 1 and with X plus what, guys? Plus ARR of L plus 2 and with X, so on and so forth, plus ARR of what, guys? Plus ARR of R ampersand with X. This value is maximum possible. Okay, this expression is maximum possible, right? For every query we have to find the minimum values between this and this. Yes, I kind of agree. I was getting TLE in this one. No, in this problem you will not get a TLE, because like you have to use the prefix concept here, na, because L and R is given here. So you have to find something in L and R range. Okay, so basically, see guys, you have been you have to maximize this value, right? So whenever AND operation is given, okay, so see, you have to find a value of X such that the expression A of L into X ampersand with X plus A of L plus ARR of L plus 1 ampersand with X, so on and so forth, ampersand of and of X with all the elements is basically maximum possible in this range. So how can you get the maximum value, right? So the bit should be set. Understand that the bit should be set. So what I will do is, now whenever I am in the range, whenever I am in a particular range L to R, so if any element, understand one thing, that if for a ith bit, suppose if for the jth bit, okay, if in the range L to R, if in this range L to R, I can say that if in this range L to R, any jth bit, okay, suppose that if in this range L to R, if the jth bit is set, okay, jth bit is set, okay, if any number has the jth bit as set in this range L to R, in this range L to R, whatever elements are there, if any element in this range L to R is having the jth bit as set, then you can say that the X number should also have the jth bit as set. Are you getting my point? Okay, if any number, if in this range L to R, any number has the jth bit as set, okay, then you should set the jth bit in I also. Is this part clear? Please write yes or no. Are you getting my point? That if you have this range L to R, okay, if you have this range L to R, so any number in this, any element in this range L to R, if it has the jth bit as set, so that jth bit should also be set in X, so that the ampersand bit can become 1. Is that clear? Please write yes in the chat. Are you getting my point? Suppose that there is a range L to R, and suppose that in this range, the j is equal to fourth bit is set. Suppose that fourth bit is set for any of the elements in the range L to R. Then in the X also, in the binary representation of X, the fourth bit, okay, the fourth bit, or you can say the jth bit, should be set in it also. It should also be 1, so that it can so that the ampersand can give me the value as set. Is that clear? Set bit means that when the bit is 1. Is that clear, guys? Yes or no? Please tell me. Okay, so what you need to do here is, see, understand one thing. What you need to do here is, you need to iterate. Okay, first of all, you will take the prefix sum. What you will do is, see, since we, like, how can we check that? So basically what I can do is, I can, like, if I am in a range L to R and we are talking about the jth bit, okay, if the, suppose that jth bit is set in this range L to R, if any element, okay, if any element is there which is having the jth bit as set, so in that case you will say that in the element X also the jth bit should be marked as set, right? That is what you have to, do. So that so what you will do is, you will be, how will you check that whether the bit is set or not? So you can use the prefix sum concept, that you can do P of R, okay, P of Rj, suppose prefix of Rj minus, let me write this. So you will generate a prefix array, that I will tell you. But basically what you can do is, if you can do something like this, minus prefix of L minus 1 j, okay, if it is greater than 0. If this expression is greater than 0, what does this mean? Basically what we will try to do is, we'll try to check for all the jth bits. Okay, jth bit can start from 0 till 31. So basically you will check for all, like, basically you will check that in this range L to R, if the jth bit is set. So this means that if any of the numbers in this range L to R has the jth bit as set, then this value will come out to be positive. It will come out to be greater than 0. Is this part clear to you guys or not? Please tell me. There's a prerequisite that you should know that P of R minus P of L minus 1. Do you know this concept of difference array, guys? Yes or no? Please tell me. Do you have an idea about this concept? Then I can tell you further. Go slow, man. Yeah, I am going slow only now. Okay. So see, basically what I'm trying to say is that no, many people are saying no, yes, okay. Where to learn this concept from? There is one concept that is known as difference array. Okay. There's this concept, update query in this much time, or let's say if I have to share prefix sum. Sum of range, yeah, you can see sum of element in the range L to R. So repeat the last line you have written. Okay, I'll repeat it, give me a second. So basically this concept is there, prefix sum array concept. If you don't know, then I will show you here. Okay, Jha is saying not able to apply prefix concept. No worries. Basically, see guys, what I'm I'll tell you about that concept first of all. Okay, suppose guys there's an array, right? Now suppose there's an normally suppose there's an array. Now what happens in a normal array is if you have the range L to R. Okay, in a normal array when you have the range L to R. So if you suppose there's an array, okay, and in that array I'm asking you the sum of the elements from L to R. If I'm asking you the sum of elements from L to R, so in the worst case, for one time, if I'm asking you the sum of the elements from L to R, how much time it would take in the worst case? Can you tell me? For one query, it would take order of n time. If L is standing at the beginning of the array and R is standing at the end, then finding the sum of the elements in the range L to R will take order of n time. Please write yes in the chat. Are you clear with this part, guys? Yeah, both the questions, second and third, will require this thing only. Yeah, fourth will also require prefix. You're correct. Okay, so yeah, basically what I'm saying here is that if you have the range L to R, then in that case, if you have to find the sum in the range L to R, so normally if you'll iterate from the L index till the R index and find the sum, so that will take order of n time. Okay, so if I ask you k number of times, if I ask you for a L1 R1, that what is the sum of the elements in the range L1 R1, then after that L2 R2, what is the sum of the elements in the range L2 R2? Okay, then after that I ask you what is the sum of the element in the range L3 R3. So if for one time I'm going to ask, so that is going to take how much time, guys? Order of n time. So if I'm going to ask you about this, how many times? Q number of times. Okay, Q queries I'm going to ask. So that is going to take n into Q time. Now is that clear? Please write yes in the chat. Does this make sense? Does this make sense? That if I ask you for one time, if I ask you to find the sum of the elements in the range L to R one time, so that would take order of n time, because you're going to iterate in all the elements in the range L to R. If I do what? If I ask you for Q queries, that would take n into Q time. Clear? Please write clear in the chat and then I will proceed further, guys. I know many people already know this, but I still have to explain this because some people don't. Okay guys, clear? Now what will happen here is what will happen is when you use the concept of prefix sum, now then you are able to, then you can answer the query of sum in the range L to R in how much time? In order of one time. Okay, how? I will tell you. Because what will happen here is, suppose that array is there, okay, and in this array I have got what? Let's say I've got 7, then I've got 5, then I've got 3, then I've got 8, then I've got 1, then I've got something like let's say 10, and then I have got something like 2 as well. Okay, suppose these are the elements that I have got. Now what you do is you take the prefix. First of all, you take the prefix sum. Now what does that mean? So basically keep on adding the cumulative sum of the elements. Okay, here so far the sum will be 7. Here the sum will be how much? 12. Okay, then till here the sum will be what? The sum before plus this particular element, so that will be 15 here. Okay, then till here the sum will be what? 23, I guess, right? Here the sum will be 24. Here the sum will be 34. Here the sum will be how much? 36. Is that clear? Please write yes. Okay, once you have done this, so basically what have I done? Basically P of I is nothing but P of I minus 1 plus A of I. Is that clear? And here you can understand one thing, that P of 0 is equal to A of 0. Okay, The zeroth guy is the same. Okay, like the prefix of 0 is same as a of 0, first of all. Okay, that is what we have done here. Then after that, the from I start from 1, you can say that p of I is equal to nothing but p of I minus 1. Okay, whatever was the prefix sum before, plus the ith element. Is that clear, guys? Okay, once you are clear with this part, so you can understand that p of I tells me what? Understand one thing, that p of I is always going to tell me about the sum of all the elements from a of 0 till the ith element. Okay, you can understand this. If I am at this ith index, so okay, so 23 tells me what? 23 tells me about the sum of all the 23 tells me about what? 23 tells me about the sum of all the elements from the 0th index till this particular ith index. Is that clear? I hope that is loud and clear to all of you. Right, because 7 plus 5 is what? 12. 12 plus 3 is 15, and 15 plus 8 is 23. Right, so I hope that this part is clear. Right, now suppose if somebody will ask me about the sum in the range L to R, and so what will be given to me? Suppose somebody asks me what is the sum in the range L to R. Can you guys tell me what? Honestly tell me, what is the sum in the range L to R here? L value is what here? L value is nothing but 2 here. Okay, and R is how much? 3 4 5. R is 5 here. Okay, according to indexing. Can you tell me the sum of the elements in this range, guys? Can you tell me the sum of the elements in this range? Count it normally and tell me. Can I say that the sum is nothing but as far as I can see it is how much? 22. Right, guys? Please comment in the chat. You have to be interactive. Please don't be silent, and hit the like button for the video as well, guys. Okay. Right, yeah, 22. Now, what you do is, what is P of R? What is P of R? Can I say that P of R tells me the sum of all the elements starting from here till here? Okay, that is what P of R tells me. P of R tells me what? Prefix of R will tell me what, guys? Okay, prefix of R will tell me the sum of all the elements from starting till this particular point. Agree? Okay, P of R will tell me about this. So P of R will be what? 34. Okay, P of R is what? 34, guys. Okay, how much sum do I want? I only want this much sum. I only want this much sum. P of R tells me the sum from the starting till the rth index. But I don't want which sum? I don't want this much sum. I don't want this much sum. So from the starting, I don't want this much sum. So can I say that uh, like I want the sum from L to R? If I have the total, suppose if I access P of R, so prefix of R will tell me about the sum from the 0th index till the rth index. But I only want the sum from L till R. So I don't want the sum from 0 till L minus 1. No? 0 till L minus 1, I don't want the sum. So subtract P of L minus 1 from there. Once you subtract P of L minus 1, so P of L minus 1 is what? P of L minus 1 is nothing but this particular thing. Okay, so here you have got 12. So subtract 12 from it. What do you get? You get nothing but 24, because in this range the sum is 24. And for accessing the array elements, it takes order of 1 time. That is why you will be able to answer query in linear time. Is that clear now? Guys, please tell me. Is this concept clear now? See, P of what happens? P of R will tell me the complete sum from the 0th index till the rth index, but I don't want the sum of the elements from the 0 till L minus 1th index. So that can be indicated by P of L minus 1. Once I subtract that, so I'll get the exact value. No? Please write clear in the chat if you are clear with the prefix sum part. Obviously, I should have not explained this, but still, if many of you don't know, so I've explained it. Okay, so everyone can hit the like button, guys, and let me know if you're clear. So far, guys. Pradeep Patani saying clear. What about others? Others who are learning it for the first time. Tejas, are you clear with this? VPN, are you clear with this? Naidu, are you clear with this? May Deepak, are you clear with this? Jatin, what about you? Guys. Okay, clear now. So this will be able to answer every query in order of 1 time. Every query L to R will be able, you will be able to answer in order of this much time. Okay, so yeah, now another thing is, suppose that if my L stands at 0. Okay, so what you need to understand is that suppose if your L value is 0, no, if your L value is 0, then in that case R minus L minus 1 will not exist. Then you will only answer P of R there. Okay, because if L is 0, suppose if L is 0 and a particular R has been given, then the question wants that you give the sum of all the elements from 0 till the rth. So that will be nothing but P of R only. No? Clear? Proceed fast. This is easy stuff. I'd love to have your LinkedIn. Yeah, you can search my name, YASHDWIVEDI. Okay. Which question? Second question we are talking about. Okay. So yes, now what you will do is you will iterate for every element in that range. Okay. So see, what you will do is, let's say you will first of all declare a prefix sum array. Okay. Why we will declare a prefix sum array? We will declare a 2D prefix sum array. Why? Because in the range, like if I am talking about the jth bit, now let's come back to this question. If you are having L and R, okay. Now in this range L to R, if any element has the jth bit as set, okay, if any element in this range, any element in this range L to R has the jth bit set, okay, if the jth bit is 1 in any of the elements, then in the X also the jth bit must be set, okay, must be set. So that jth bit, like basically if jth bit is 1 in any of the numbers in the range L to R, then in X also that jth bit should be set. So basically the number should be updated with 2 to the power j, or you can say 1 left shift j, because 2 to the power j can be indicated as, in bitwise we represent it as 1 left shift j. So what I'm trying to say here is that firstly we need to have a firstly we need to have what we need to have a prefix array. So what you will do is, like, let's take a prefix array. So vector of vector. So like long, and why am I taking a 2D array? Because if you will see, so I need to check. Okay, so P of R0 minus P of L0, because I want L minus 1 0, because I want to check for every number. Now see, I want to check it for the 0th bit. So I will check what? I will check P of R0 minus what, guys? Minus P of L minus 1 0. No, I will check this for the 1th bit. What am I going to check? For the 1th bit, I will check P of R1, okay, minus P of L minus 1 1. For the, let's say, j is equal to 23rd bit, what will I check? So I'll check P of R23 minus P of L minus 1 23. Okay, this is what I will check. That is why I need to take another dimension, because the other dimension is going to tell me which bit I am checking. Okay, is that clear? So firstly, obviously I'll be generating this thing, then after that you will do it. So let's declare this array, prefix array. Okay, now once you have declared the prefix array, guys, so what you will do is, you are already given n, so let me declare a prefix array of n plus 1 size. Okay, then after that you will write what? Vector of long then 32, and initially I'm marking my prefix array as 0. So basically I have declared what kind of a prefix array? I have declared a prefix array of how much size? N plus 1, okay, into 32 size. Okay, because the bits will be from where to where? The bits will be from 0 till 31. No? That is why. Now what I will do is, I'll iterate for every number. Okay, so like I start from 1, I is less than equal to n, I plus plus. Now understand what I will do here. Okay, so I will like for the ith number that I am at. Okay, so for the element that I'm at, I'll tell you. Okay, let's write it as element. Let's say int element, okay, is equal to what? Let's say int element is equal to ARR of I minus 1, because the array indexing is 0 based now. So if I am starting my I from 1, so it will be 0 based, right? Now once I am into this, so what I will do is, like, I'll say that we will iterate for all the bits from 0 till 32, and we will check. What we will check is, like, we are basically going to check that going to basically check what, that if it happens, right? Suppose that if the element has that bit as set, okay, if the element left shift with j, because you are checking if the jth bit is set or not. So if the element left shift with j and with 1, if it is suppose equal to 1, so if that bit is set, okay, then you are going to do what, guys? Then you're going to say that prefix of ij would be equal to nothing but prefix of I minus 1, okay, j, because you are going to cumulatively take the sum. So I told you na, prefix of I minus 1 concept already, plus 1, you're going to add 1. Otherwise if it is not set, okay, if it is not set, then whatever is the previous prefix sum, if suppose this element value is 0, you can say, right? So in that case, what you will do, you will just directly take forward whatever is the previous prefix sum. No, are you getting my point, guys, here? Okay, so once you have stored this, then what we will do here is, after this you will iterate again throughout throughout all the queries. So you can say that we need to have a vector like vector, let's say int answer, which will be of q size, and let's say index will be 0 like all the elements I can mark as 0, then I'll iterate. So I'll say that I starts from 0, then I is lesser than q, then I will do what, I plus plus, and after that let's say int l is equal to what, queries of I 0. Okay, then int r is equal to what, guys, queries of I 1. Okay, then after that, like once this is done, then what will I do? I'll say that answer of I would be equal to what, guys? It will be equal to nothing but what can I say? So just a second. So what you can say is that if you are iterating, so you'll iterate for all the bits basically, no? So once you have got your L and R, no? So what you will do is you'll iterate for all the bits. J start from 0, J is less than 32, and J plus plus, and then after that, you will do if suppose that what happens is P of Rj, sorry, prefix of Rj, Rj minus what, minus the prefix of L minus 1 j. Okay, if this is greater than 0, so if the jth bit is set in any of the numbers in the range L to R, if the jth bit is set in any of the numbers, then what you will do is you will increase your answer by that many bits for that, like for that. So let's say I will do one thing, I will also declare let's say int x initially as 0, and you will say that you will increase the x value by that many bits, so 1 left shift j. Okay, and once you have done that, so once you're after that you will keep on doing it for all the positions. Okay, in this range L to R, you will iterate for all the positions and check if the jth bit is set, then in that case you need to increase your answer x value by that many bits. So you need to mark this jth bit as set in the x also, no? So that is why you will do 2 to the, you will add 2 to the power j in your answer. Okay, and once this answer is prepared, then you will store this x value in your answer. Okay, and then at the end just return this list. Okay, is everyone clear with this, guys? Please tell me. Let's try and run it now. It says that there is some error. What is the error? Long. Okay, long is what I should declare here. Let's try and run it again. Okay, then we are having this issue. Okay, so yes, I have made one mistake here. Yeah, every time x will be renewed, like for every I want to find the minimum, no? So every time, like this is fine basically, because for every element you will be iterating. So wherever you have the L to R range, so your X will be fresh every time, no? You will be restarting, and then you will figure out. Let's try and submit. Let's see if it gets accepted. Yeah, it gets accepted. You have to reduce it to 0. Yeah, every time you can see now it is becoming 0. So you can see it gets accepted as well. So is this problem clear to everyone, guys? Please write yes or no. L can be 0. Are you sure L can be 0? No, because you can see the queries are given from 1 to n. No? VPN user here L minus 1 is not a problem, because L and R will be given from 1 to n, capital 1 to capital N. That, like, sorry, from 1 till n. So basically plus 1 base indexing. Capital N and capital N and R will be given, the L and R will be given from 1 to n. So that is why this will not be a problem. Make sense? Okay, I also tried with the same segment trees overkill. Yeah, you don't need search set bits का कैसे पता चलेगा? Basically, Harjot, for set bit na, you can use the right shift operator whenever you want to check in an element whether the jth bit is set or not. So you can do element right shift j ampersand with 1. If it is 1, then this means that element, that jth bit is set. Otherwise, it is not. So can we move further, guys? Ashish Kumar says explain again. Priyanshu, if you don't want to be here, so you can leave, I guess, right? Okay. Uh, See, my responsibility is that everyone should be clear with this, right? Okay. So you can see here, guys, what you need to do is you need to iterate in, I'll tell this again. Okay, see, basically, I am given a range L to R. Okay, every time I'll be given a range L to R, I have to check that if suppose that the jth bit what I have to do is understand one thing why I'm building this prefix array, because every time I'm given a range L to R, then initially my x is 0. And in that x, I will increase it by 2 to the power j if the jth bit is set in any of the numbers. Then in my x also that jth bit should be set. So that is why I'll iterate, like I will check that if in this range L to R, so basically if P of R j minus P of L minus 1 j, if it is greater than 0. So if there is any number that in the range L to R that is having that jth bit as set, that jth bit as 1, then in that case my x should also have that jth bit as 1. So that is why I'm increasing my x with 2 to the power j. Okay, and once I have done it, checked it for all the bits, then after that I'm updating my answer of I, that for that ith query I'm updating my answer to x. Clear, guys? Okay. And what I have done here, so basically it's just like your jth bit remains constant. So for every element, for any particular element, what you will do is you'll iterate for all the bits. Okay, if the jth bit is set in that element, then what will happen is your prefix sum ij will be nothing but whatever is calculated previously plus 1 also, because this because in this number also the jth bit is set. Otherwise, if it is not set in this jth number, then it will just be the previous only, no? Is that clear, guys? Now you can tell me. Makes sense? I will just generate the link for it as well. Okay, yeah. Okay, so yeah, I have shared this. Everyone is clear. You can write +2, and then I'll proceed further to the third question as well. Everyone is clear with the second question, guys? Then we'll proceed further to the third one also. Clear, guys? Pratham is saying he has done it using linear and by search. Not sure what you have done. Okay. Right. So let's try and move on to the third problem now. Okay, this is a very interesting problem now, guys. What does this problem say? Okay, it says that there is a market. Suppose that there is a market. Okay. Now, if there is a market, okay, if there is a market, so see, there is a there is a kind of a marketplace. Okay, and in that marketplace, the stalls are there. Okay, so you have been given an array ARR, and this is the marketplace. Okay, so for every store, like ARR of I indicates what? ARR of I indicates ARR of I will tell you about the sum. Okay, ARR of I tells you about the cost, like what you can say, the cost of the flour, right? What is the value? Customers. L the ith, yeah, cost, like cost of the ith stall, cost at the ith stall, you can say cost at the ith stall. Okay, now what this guy is saying, see, you have been given like AR of I indicates that what is the cost at the ith stall, suppose. Okay, that is what has been given to you. Now it says that like you have been always given L to R range, and you have to tell that like you can do what. See, you have been given the costs of these segments. So I'll just quickly do it. Let's take this range first of all. Suppose that you're given the range what, like let's say you're given multiple ranges L to R. Suppose you have been given 1 3, then you have been given what, 2 4, then after that you have been given 3 4 also. Okay, so suppose that you have a number line. Okay, you have the indexes from 1 to 4, let's say. Okay, so you have all these indexes. Now first of all they have said that you have to consider this particular range, that is 1 to 3. So in 1 to 3 the people are visiting, suppose. So from 1 to 3 people are visiting, all right. From in this range people are visiting, okay, that's fine. Then after that they are also telling that people are visiting in the range 2 to 4. So from 2 to 4 people are visiting, okay, in this range till this range, okay. Then after that people are visiting also in the range 3 to 4, so kind of in this range till this range. Okay, let me remove this array now. Okay, can you like, so yeah, you can see here, this is the thing, this is the scenario, guys. right? So people will be visiting, right? Many people suppose are visiting, like every time, suppose one person is visiting the stalls in the range L to R this much, then 2 to 4, then 3 to 4. So you can do what? You can rearrange the shops. Okay, see what I will tell, like what I will show you is, suppose, see, all of you have understood this part, that maybe some people are visiting from the stall 1 to 3, then some people are visiting all the stalls from 2 to 4, then some people are visiting all the stalls from 3 to 4. So suppose that if this is a number line where you have been given the stall number from 1 till n, okay, and then after that, suppose that like from this stall to this stall people are visiting, then what happens? People are visiting from this stall to this stall. Then what happens? People are visiting from this stall to this stall. Okay. Then tell me, guys, tell me one thing very importantly, that which stalls are being visited most of the times, because you have to maximize your profit. Okay, so you have to maximize your profit. So what you have to do is you have to maximize your profit. If you have to maximize your profit, so at which shop you will keep the expensive gifts, at which shop you will keep the expensive items? Tell me. Right. Yes. Can I say that the indexes, that the shops which are visited the most, okay, the shops that are visited the most, these are the shops that are visited the most. You can see here the ones that I'm highlighting with the red color. Okay, the shops that are visited the most, you would like to have, like you would like to have what? You would like to keep the higher prices at those shops. Is that clear, guys? Are you clear with the intuition part for this problem? Suppose that people are visiting L to R ranges. Okay, now one time L to R can be this green range, then this pink range, then this white range that I've highlighted. Okay, and shops are supposed from 1 to L. So whichever shops, like you would like to keep the maximum element, since you want to maximize your profit, so you would like to keep the items which are having maximum value at those indexes which are visited most of the times, or at those shops which are visited most of the times. Is that clear? Please write yes in the chat. If everyone is clear with this idea, you can tell. Very basic, greedy approach. Are you clear with this? Okay. And whichever shops, where will you see, you can say that you will keep, suppose that you will keep the maximum value at this place, right? You will say that you will keep the maximum value at an index which is visited the most. Okay. Where will you keep the minimum value then, guys? Where would you like to keep the minimum elements? The minimum prices you would like to keep at which kind of indexes? Which are which are visited the least number of times. Correct, guys? Is this part clear? If you're clear with this, please hit the like button and let me know if you're clear with this. Are you clear with this part, guys? No one came. Huh? What? No one came. Yeah, where no one came, or basically the where the visiting is the least. Okay, so suppose if somebody is visiting, then how would I be able to figure that out? Okay, so let us, like, there is one concept that is there, that is again a prefix sum concept. So let me explain how you would identify that which shops, like basically the thing is that how to identify, okay, which shop is visited how many times. How many times in total. Okay, so that is one thing that is very important, because you need to know that total number of times, which shop, like every shop has been reached how many times in total, right? So what I will tell you is there is another prefix concept that is there. Okay, suppose that, see, if suppose that somebody tells me, suppose that somebody gives me this array. Okay, let's say this index is basically 1, and this index is what? Let's say something like 5. Now this is 2. Okay, suppose this is 3, suppose this is 4. Now if somebody tells me that you will be given L to R index, okay, and you have to do what? Increase every element by 1. Okay, what you have to do? If somebody tells you to increase every element by 1 in that range, then in normal approach, in the brute force way, how much time it would take? Can you tell me, guys? In the brute force approach, how much time it will take if you have to increase every element in the range L to R by 1? You will go to every element and then increase. So that would take order of n time. Agree? For one query, if you are going to update that in L to R, all the shops from L to R were visited, so you will add 1 to them, then you will take order of n time. So if you are given q queries, then you will take how much time? N into q time, no? Is that clear? How is solved out 2 out of 4? Very good, very good. Yeah, it would take a, like it would kind of be squarish in nature now, because if you update L to R, L to R is there, and you are updating every element by one, because every shop you are visiting like one time each in the range L to R, right? So then if you update for one L to R, then that would take order of n time. So for q queries it would take n into q time, which is quite a lot. Okay, but you can do it in a better fashion. How? Let me show you. Okay, what you can do is basically, if suppose L is given as uh 2, okay, and R is given as what, suppose 4. So what you do is, you at this place you add plus 1. Okay, like basically what we do is, you increase the L, P of L plus plus is what you do, and P of R plus 1 minus 1 is what you do. Okay, minus minus. So at this place you will add what, 1. Okay, this guy will become 1. Understand this thing. Then after that what will happen, guys, is at this particular place R plus 1 is what, this place you will add minus 1 to it. Is that clear? What I've done is, like, please write clear in the chat, CLR in the chat if you're clear. As of now, what I'm telling is that if you have to update in order of one time, so what you do is, like, whatever L and R are given at P of L, you increase it by 1. Okay. And at P of R plus 1, you subtract it by 1. What happens then? Then in that case, at 2 you are adding plus 1, and at 5 you are adding, like, you are giving minus 1. Okay, if you take the prefix sum at the end, what will happen? Can you tell me, guys? If you take the prefix sum at the end, so you can understand one thing, that here the value would be 0, here it will be 1, then here also it will be 1, because you keep on carrying, like, adding forward the values. No, here it will be 1, and here it would be what, 0. Are you getting my point? That if you will take the prefix sum 1 last time at the end, so it will tell you the total number of times that the range, like, it will update once you at the last time after updating for all the queries. Now if you will iterate the last time, so then you can see that when you will iterate, so here the value is 0, here it is 1, here it is 0 0, then minus 1. So when you will take the prefix sum of this array, so it will be like 0 1 1 1, then 0, because minus 1 and 1 will be 0 now. Are you getting my point, guys? Here, please write clear in the chat. Is this part clear to everyone so far? Yes or no? Now suppose that if somebody also tells me, see, people are like, suppose that in this range you had to update, okay, like, if you had to do what, obviously, as I said, if you had to update this all these elements, right? Now if somebody asked me that you also have to update the elements in the range, let's say what, in the range, let's say 2 to 5, suppose, okay, suppose in the range 2 to 5, let's say in the range 3 to 5 also, like, suppose in the range 3 to 4 I have to also update. Okay, so in the range what, L is equal to 3 and R is equal to, let's say, 4. Okay, suppose this thing is also there. So what I will do, at P of 3 I will increment. Okay, and at P of 5, because P of R plus 1 I will subtract now. So what I will do here is, at P of 3 I'll increment. So here the value was already 0, so I'll add it by 1, so it will become how much? It will become nothing but 1 here. Then P of R plus 1 I'll subtract, so now it will become what? It will become minus 2. So understand one thing, guys. So far what have I done? Basically you can understand that if the values were 2 4 2 3 and 4, okay, so what you have done is, you have iterated in the range 2 to 4 like this. Okay, you have updated one time like this, and then 3 to 4, so 3 to 4 is like this. Okay, so basically how many times you have visited the shops? Shop number 2 has been visited how many times? Mansha is saying not clear. Which part is not clear, Mansha? Which part? Did you join in between? Now see, what will happen is, if you, okay, I'll tell you. Let me take one simple array that will be better. Okay. So what I've told is, remember this thing. I have told that what you will do is, you will increase the P of L by 1, and P of R plus 1 you will subtract. Okay. So suppose this is the array. So this index is what? Suppose 0, then 1, then 2, then 3, then 4, and then 5, suppose. Okay. Suppose these are the indexes that you have. Let me take one more index for better clarity. Okay. Now what you will do is, this is the P array initially. Every element initially would be nothing but 0 here. Okay. Now suppose guys, what I do is, if this is the range that has been given to me, okay, now what I do is, if I tell you that I will update the elements from 3 to 5, okay, by 1, then what will happen? This element is 3, then 4, and then 5, and then 6. Okay, so if I say that I will be visiting the shops from 3 to 5, that is the first thing that I'm saying. Okay, then after that I am like, suppose that this is 0, okay, suppose this is 1, this is 2. Now after that, suppose I will also tell you this is one LNR range, and suppose that another range I would tell is, let's say, 1 to 4. Okay, that I'll be visiting the shops from 1 to 4 as well. So 1 is here and 4 is here, so I'll be visiting these shops also. So can you tell me guys, total number of time, like, so see, this is what I'm saying. Okay, now if you see here, so firstly what has been given to me, firstly P, 3 has been given, then 5. So this is L, this is R. So at P of L you update it by 1, so this becomes plus 1. Okay, you update it by 1, it becomes plus 1 here. Then after that, P of R plus 1 you subtract it by minus 1. Okay, R plus 1 is what? 6. So that is why you will update minus 1 here. Okay, then after that, what you do guys is, after that what you do is, you have been given 1 and 4, so at P of 1 you update it by 1. Okay, so already 0 was there, so when you do plus plus, it becomes 1. Then at P of R, if R is what? 4. Okay, then R plus 1 will be what? 5. So at this place you do a minus 1 after that. Okay, then you take the prefix sum. Now take the prefix sum of this whole array. Take the prefix sum of this whole array. Okay, take the prefix sum of this whole array. What will happen? Now when you take the prefix sum, this element would be 0. Okay, this element will be how much? 1. This element would be how much? 1. This element will be how much? 2. This element will be how much? 2. Okay, this element will be how much? 1, because 2 then minus 1 will be 1. Then this element would be how much? 0. Okay, so you can see that once I have updated now, then after that, at the end you take the prefix sum. And how many times, if you will see here, look at this and draw these shops. So shop number 0 has been visited 0 times, shop number 1 has been visited 1 time, 2 has been visited 1 time, 3 has been visited 2 times if you see the diagram. Okay, shop number 4 has been visited how many times? 2 times. Shop number 5 has been visited 1 time, 6 has been visited 0 times. Okay, that is what the final prefix sum is also indicating now. Is that clear guys? Yeah, it is about prefix sum only overall. Is that clear? Everyone, please tell me. Are you getting my point? What you do is, every LNR range is that is given now. So now you do what? For every range L to R, you update in order of 1 time, and last time you take the prefix sum. So only 1 time you are iterating throughout the array now. And every update you are doing in order of 1 time. Is that clear to everyone? Okay, so because of this, what will happen now? Which shops are there? Tell me guys, in this which shops are there which have the which shops are there which are visited the most? Can you tell me? Can you tell me guys? Shop number 3, like this shop and this shop, right? This particular shop and this particular shop, correct? So wait, Sachin is saying wait, for which part you need to wait? See, the shops which are visited the most, they will, highest prices you will multiply with them, no? Highest ARR values you'll multiply with them. But Noob, if you take only 3 to 5, then 5 will also be visited. If you take from 3 to 5, yeah, so 3 to 5, so 5 is visited 1 time here, no? But it visited 1 time. If you take 3 to 5, then 5 will have 0, but it visited 1 time. No, because if I am taking 3 to 5, so I am visiting 5. When I'm taking 3 to 5, so I'm doing what? P of L plus plus and P of R plus 1 minus minus. So basically you are visiting the shop number 5 also. It is included. Shop number 5 is also included. Okay, I'm including all the shops from L to R. I'm visiting all the shops from L to R. Clear, Sachin? Makes sense. You can tell me, then only I'll proceed further. Guys, is this part clear so far? If you're clear so far, guys, for the effort, you can hit the like button. Okay, if you're clear, you can write +1 in the chat so that we can proceed further also. Right. So what you would do here is, guys, understand one thing, that what we will be doing here is, like, I will take a prefix array, suppose. So let's say what I will do is vector, let's say int. Okay, and then let's say I'll take a prefix array here, and that will be of size n. Initially, I'll mark every element, suppose, as 0. Then after that, we'll iterate. So int I starts from 0, I is lesser than n. Then I will do an I plus plus here. Sorry, I is less than m, because m is the size of the order array. No? So you'll iterate for all the elements in this range, and let's say L will be what? L will be, let's say, order of I0. Okay, for that query, and then R will be what? Order of I1. Okay, then after that, once you're done with this, okay, then I guess they have given me one base indexed. Yes, so here I can do what? If you want to be 0 base index, so I can do L minus minus as well as R minus minus. Okay, so that I can have a 0 base indexing. Now after that, what I said was that I will do what? I will do prefix of L plus 1, sorry, L plus plus. Okay, you will increase the left, as I said, and then R plus 1, you will do minus minus. But can you always access R plus 1? No. If the R plus 1 is less than n, then only you will be allowed to access it. Otherwise, don't access it. Okay. So is this much part clear? Or did I made some mistake? No. Prefix will be of n size only. No, it will be the size of the. No. Prefix will be for the size of array only. No. M is what? M is the number of stalls, and M is what? No. It is fine. I think it is fine, because prefix will be the number of indexes that is there in the array. No, Manish. Yeah, so Nilesh is saying that they could have given prefix some basic question in the first also, so that everything would have been covered in prefix. Yeah, maybe. So yeah, you can see here that like L and R you have taken. Then since they have given one base indexing, so I have done L minus minus R minus minus to get it 0 base index. Then I will always do L plus plus. Okay. Then I will do R plus 1 minus minus, but R plus 1 index should be present. So that is why I'm checking if it is present or not. Okay, then after that, I will do what? I will sort both the arrays. Okay, so what I will do is I will say that I will sort both the arrays in the ascending or descending, whichever order you want. Let's basically the elements which are visited less number of times, I will multiply them with lesser ARR of like with lesser element of ARR. The shops which are visited most number of times, I will multiply them with higher elements of ARR array. So what I will do is I'll sort this prefix array from the beginning, comma prefix dot end. So I'll sort it from the beginning till the end. Okay, then after that, what I'll do is again I would sort the prefix dot begin, okay, comma the prefix dot end. Sorry, not the prefix, the ARR array. Okay, ARR dot begin, comma the ARR dot end. So I'll do what? I'll basically say that I will sort the prefix array. That is basically the shops that are visited now. How many number of times? So the shops that are visited least, they will come in the starting, and then similarly the ARR array, whichever prices are less, they will come in the starting. Okay, so whichever prices are higher, they will come at the end, and whichever shops are visited higher, they will also come at the end. So what will happen now is, now after that, I will take a long, let's say, answer initially as 0, and then what you need to do is you need to say that now you will multiply. So int I starts from 0, I is lesser than n, I plus plus. Now basically what will happen, the lower price will multiply with the lower sir, you need to add elements of prefix. Yeah, correct. Sorry, I forgot about it. One more time, I need to finally take the prefix sum. Yeah, as I said, like after updating the queries, then I will do this thing. So prefix of I is equal to prefix of I is equal to prefix of I plus you can say what, prefix of I minus 1 is what you need to do. Okay, and yeah, you need to start your prefix from 1. Okay, so see, once you have taken the prefix sum, then what you will do is you will sort this prefix array. Okay, and basically whichever shops are visited least, they will come in the starting, and whichever prices are less, they will come in the starting. So less shop visit will multiply with less price. Okay, the shop visit which is visited the most, it will come at the end of the prefix array, and it will get multiplied with the highest element with the highest cost. Okay, so what you need to do is answer is equal to you can say answer plus what, the ARR of I into one long y I'm doing, because if you multiply int into int it will overflow. That is why you need to multiply long also, so that it can be long. Okay, now ARR of I into prefix of I. Okay, this is very important, so that I can, because if you multiply int into int it will be int only na. ARR of I is int, and the prefix array is also int. So if you want to do what, if you want to make them long, because when you multiply it might overflow, so that's why you will directly do this. And then you can take the modulus here, I guess, because they are asking you to take the modulus. So one time take the mod here, another time take the mod here, and let me declare the mod value. Let's say long mod is equal to what, 10 to the power 9 plus 7. That is what they have asked me to take the modulus. Okay, so that is what I'm doing here. Then at the end, I guess I can just return the answer here. Let's check. Okay, my name is Man. Okay, so in line number 26 I am missing a colon here. Okay, let's try and compile again to check what happens. Works fine on the sample, should get accepted, I think. Let's see. So yes, it does get accepted. So is this problem clear to everyone, guys? What you do is just like, since you have been given one base index and your array is zero based, so what you do is like, first of all, L minus minus R minus minus, so that L and R are zero base index. Okay, and then prefix of L you can increase, and then R plus 1 you can subtract, but check if R plus 1 is available, then only do so. And then after that declare modulus at 10 as 10 to the power 9 plus 7, and then take the prefix sum finally, so that you can get how many times a shop, what number of times ith shop is visited. Then after that sort both in ascending order. So the price, if the price, less price into less shop visit, highest price into the shop that is visited the most number of times. Okay, that is what you multiply. Okay, and then you just return the answer. Can you explain that mod thing? Basically, why am I doing this mod? So basically we are doing the like the man, basically why we do this modulus, because the answer will overflow when you multiply a lot of higher values now. So it will even exceed the long limit. Okay, so then you will not get a direct accurate answer. So that is why they are taking the modulus with a very high prime number, because 10 to the power 9 plus 7 is a very high prime number. Okay, because if you keep on adding, so it will exceed the long limit. So in order to keep it maintained, you are taking the modulus so that it can still remain in the long thing. Clear with this, everyone? Please write clear in the chat and hit the like button, guys, if you're clear with this problem, and then we'll proceed further to the last problem now. Is everyone clear? Sachin, thanks a lot, man. Yeah, please hit the like button, guys. I am explaining everything from scratch, so you can hit the like button, and if possible share it with your friends also. Okay, it should be justified. The like counter doesn't justify the effect, like the effort. Okay, whatever discussion we have had so far now, whatever brainstorming we have had so far, so today you got to learn about prefix sum concept, right? So normal prefix, like, see, first question was very easy. First question was what, like a normal easy question, right? B mod, only you had to check that if b mod 2 is equal to 1, if it is odd, then not possible. Okay, then second question, in second question you learned about p of r minus p of l minus 1 concept. In the third question you learned about the difference array concept, right? Where you did what, p of l plus plus p of r plus 1 minus minus now, these things. So every question had to offer something. Every question offered something or the other. Okay, so after this stream is over now, you can tell that yes, you enjoyed the session. Like, once the stream will get over, so mention it, that yes, you enjoyed the discussion, you like the discussion. Because what happens is, whenever something goes good, like if explanation is good, nobody says anything, but when something goes down, they start shouting. So if the explanation is good, if the effort is there, okay, then you should also comment after the stream is over. Okay. Yeah, so I hope that you all are clear, and yeah, you can tell me what you all are doing right now. Okay. Yeah, so we are only left with one more problem. But yeah, to be honest, the second and the third problem was good. Third one was easy. Third one was easier compared to the second one, I guess. Second one, like both were fine, I guess. Right. Dinner. So yeah, what are you doing right now? Like holy celebrations or what? After this stream will be over, like I hope that in the comment section you'll write happy Holi as well, okay? Is the concept called as prefix sum? Yes, basically the last this particular concept is the like see normal prefix sum is there. Then this particular concept you can say as prefix sum. This is called as difference array concept. Okay, difference array concept. If you want, like if you want to read, you can read about it. But obviously I've explained it, right? So basically something of this kind: difference array range update in order of one, something of this kind. So you can see here, no, they are doing this thing. Even if you want to update it with any value. So if you want to update every element in the range L to R with the value is X, then you can do that. So you can see plus like the L element plus with X, and then R plus one element minus with X. Okay. Here my X value was 1. So that is why I was just doing plus plus and minus minus. But if your update value is X, then you can do plus X, and then minus is equal to X for R plus one at that. Okay. So learn this. Great, 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 Vanshika. You are from which college, Vanshika? Like from which city, basically? Okay, so yeah, everyone is clear with this. Can we proceed further to the last problem? Okay, just before that, give me a second. So basically, in this problem, I did face a bit of difficulty because, like, for some weird reason, my code was not getting accepted. So first of all, I'll show you my code, my approach, my thought process for it. All right, just a second. Mm, thanks, thanks, thanks. Mm, were you getting TLE as well? Yes, man. I was also getting TLE. You can see here if I will copy my code that I had written for the last problem that is there, no? The last problem or the question number 4 that is there. I am also getting a TLE, but I'll still explain it. Like, I don't think it should have given TLE. Can I also share my code in the chat so that you can give me feedback? Uh, yeah, you can. I'm not sure whether YouTube will allow it or not. You can try to do that. Okay, so yeah, question number 4 basically was what, guys? Maximum subarray sum. Okay, subarray sum part 2. Okay, this is the name of this question that is there. Okay, now the approach that I was applying was n log n. Okay, but it was giving me TLE, which it should have not given. So I'll show you if this code is there that I have written, suppose. So when I will submit this code, okay, then you will see here that it is working on the samples. Okay, you can see that when I've submitted the approach, so it is working on the samples, but when I'll submit it, it will give me a time limit exceeded error. No, Kadeen will not work here because it will be n square here. Na? For one query, it will be order of n. You can see that it is giving me TLE for some reason, but I don't think it should have given any TLEs. Very strict time limit. I even optimize code a bit. Yeah, but see, if n is 10 to the power 5, then it should have not given TLE. Na? That is what I believe. So I'm not sure why it is giving TLE because, like, if you do 10 to the power 5 into 5 into log, like log n into log n, where n is 10 to the power 5, so it should have got accepted. But for some reason, it was not. Maybe somebody might have got it accepted. So I'll just check for that. Okay. But yes, let's first read the problem. Please write +1. Can we start with this problem? Okay, then we'll see this approach. Okay, so please write start in the chat or next in the chat. Okay, so that we can discuss the last problem. And also please make sure to hit the like button, guys, so that we can proceed further. And I hope that you all are promising me that after this video is over, you will tell that yes, you understood the problem, you understood the approach. Now the last problem is very easy. Okay, so I'll tell you my normal approach, like from the very scratch. I'll explain the question and everything, and slowly and steadily you will get familiar with what you had to do and everything. Okay, so yes, let's start. Right. Okay. So if you see this particular problem right here, so it says that like you'll be given an array. Okay. So basically, what they are saying is, I'll explain this question. Long story short, what I will explain here is, see, there is a original array ARR that has been given. Okay. Right. Now, what happens? There is like like suppose that there is a normal array suppose given. Okay. So in this normal array, suppose that if you had to find the maximum sum subarray, okay, so basically suppose that the elements were like this. Suppose you had 5, then you had 10. Okay, then suppose you had 0, then you had what, let's say you had 15, then you had 4, then you had 9, then you had 0, then you had what, let's say you had 11, and then you had what, let's say here you had 0, and then you had suppose 4 here. Okay, so can you tell me which is the maximum? Sir, आप बेस्ट हो अभी तक GFG कॉन्टेस्ट एनालिसिस में जितना मैंने देखा है. बहुत बहुत धन्यवाद भाई. Means a lot. Okay, so yeah, if you will see here, guys, so what is the maximum subarray sum? Okay, you don't have to and also notice that you don't have to include any elements which are 0. Okay, so see, if you see this subarray, what is the sum of this subarray? 15. What is the sum of this subarray, guys? Understand? Shubham Jha. Shubham Jha, you are what? Math. You are from Mathli area. I'm not sure. Just asking. 15 plus 9 plus 9. 15 plus 4 is 19. 19 plus 9 is 28, I guess, right? Then this will be how much? Let's say 15 only, right? So what is the maximum sum here? Please comment in the chat, guys. Yeah, Cadence would take n square. Yeah, that is fine. How much, guys? Tell me. Which is the maximum sum here? Comment in the chat. Tell me. Maximum sum is how much? Maximum sum is how much? 28. Maximum subarray sum is how much, guys? It is nothing but 28. Okay, maximum subarray sum is 28 here. Okay, very good, very good. What happens in this question is, like, they will be giving you, like, what they will be giving you, this is the thing. Okay, so what will happen is, suppose that initially the array looked something like this. So I'll tell you what this question is kind of doing with you. Okay, suppose that initially, let us suppose that initially the array was 20, like, let's say initially the array was, let's say 7. Okay, then it was 4, then it was what, let's say you had 9, then you had 3, then you had 2, 8, something like this was there. Okay, and the indexes were what, 0, 1, 2, 3, 4, 5. Suppose that they would have given you BRR of I value as what, let's say they would have given you it as to you as 3. Okay, then what you had to do was you had to mark ARR of B of I as 0. Okay, so the element at the third index you had to mark it as 0. Okay, what you had to do was you had to, if suppose that the BRR array is given, so in this BRR array whatever element they are giving here, so that guy you have to mark as 0. So this guy you will mark as 0, right? Let me just change this. Let's say this was something like 41 17 169, or let's say this element was let me change this. Okay, let's say this was something like 5, this was, let's say, 69. Okay, at this place if you had got 69, right, so you will mark it as 0. Please write clear in the chat. Okay, so what you had to do was you had to mark this as 0. Okay, DSU reverse order of BRR work within time limit. Okay, interesting. I will explain my logic and then I will try to see if somebody has done it using DSU. Then I will show you that code also. But yes, guys, like if you will see here now. So what you had to do was, see, if suppose that before this element was made 0, then they would have been a certain maximum subarray sum. Agree? Before you made this element as 0, they would have been a certain maximum subarray sum, right? But when you make this element as 0, then can I say that the maximum subarray sum would change? Right, when you make this element as 0, can I say that the maximum subarray sum will be how much now? When you make this element as 0, maximum subarray sum would be how much? Right, it would change. Please write yes. Now the maximum subarray sum will change. 10 years of experience. I didn't think about DSU, to be honest. Interesting. Okay, so yeah, basically then it will change now. So in every query, what will happen is they will keep on making the elements as 0. Okay, you can see here. I will show you. Okay, let me show you here. Okay, so suppose that this array is given to you, and it is like what? 2, then 1, then you have got 7, and then you have got 8. Okay, then after that, suppose that the BRR array has been given, it is one base index, you can see here. Okay, so 2, 4, and then 3, and then 1. So let me do the indexing here. Okay, 1, 2, 3, and 4. So if you will see here, so what you have to do is after every operation you have to tell. So after the first operation, when this element is made as 0, then the subarray will be what? The element at the index 2. So the array will become 2, 0, and then 7, and then 8. So what is the maximum sum here at this point? It is nothing but 15. Okay. Then after that, what happens is then you mark the element at the fourth index as 0. Then what is the subarray now? So 2, 0. Okay. Then you have got 7, and then you have got 0. What is the maximum sum? 7. Okay. Then after that, what you do is you will mark the element at the index 3. So 2, then 0, then 0, and then 0. So the maximum sum would be 2 only. Okay, then after that, what you do is you mark the first guy. So 0, 0, 0, 0. So the sum would be nothing but 0. It still gives n log n. DSU, I'm not sure how you guys are applying DSU. I'll check that. Okay. Yeah, is this part clear, guys? Yes or no? Are you getting my point here? Please tell me. Right. What I'm saying is, like, first of all, the element at the index 2, you will mark this guy as 0. Okay. Then, so after that, the maximum subarray sum would be 15 in the updated array. Then, if you will mark the element at the index 4 as 0, then 8 will become 0. Then 2070, then maximum element is 7, I guess. Then then after that you will mark the element at the index 3 as 0. So the array will be like 2000. So this guy. Then after that you will mark the element at the index 1 as 0. So that will be basically 2 will be marked as 0. So all the elements are 0. So sum will be 0. So you can see the answer comes out to be 15, 7, 2, and 0. Right? You can see that the final answer is 15, 7, and then 2, and then 0. Is that clear to everyone? Please write clear in the chat. I still don't understand how DSU will be applied. I'll also check that. But yeah, let's discuss the intuition first of all. Okay. So yeah, you can see here that you are having 15, 7, 2, and 0. Is that clear? Please write clear in the chat. Disjoint set union. It is an advanced data structure. Disjoint set union. If you will see now, I have explained disjoint set union in one of the streams, like weekly contest 145. I guess in that I have explained. Let me just check. I guess in weekly contest 145, which was taken by me, I have explained in that one. Let me just check. Okay, I'm not sure, but yeah, you can check that on your own. Weekly contest 145 or 146, somewhere in the last question I've explained that. Okay. So yeah, what I was trying to explain is, like, is the question clear? Please write clear in the chat so far. Are you all clear with the question? What the question expects? That after every update, you have to tell that what is the sum. After every update, you have to tell what is the sum. Right? So if one time, if for one array, you after one update, you will apply cadence, then that will take order of n time. After one update, if you apply cadence, then that would take how much time? Order of n time. Agree? So after n updates, like if for n updates, every time you apply cadence algorithm, so that would be n square. Please write yes in the chat. Plus 1 in the chat. Everyone is clear with this? If for after one update you find the maximum sum using cadence algorithm, that will take order of n time. So after n updates, if you will still apply, so it will be order of n square. Are you getting my point, guys? Here? Yes or no? You all can tell me. And please hit the like button if you're clear. Okay, so that would be n square. So basically, if you will think, okay, if you will think, see, if something is going normally, okay, if you follow the path which everyone is following, okay, then that takes a lot of time to get successful. You have to think in the reverse way. Okay, okay, are you getting my point? You have to think in the reverse way. Okay, what you have to do is you have to think in the reverse way. Okay, instead of thinking like this, what you have to think is, I'll tell you. See, first of all, in this problem also, you have to take the prefix sum of the array, because you need the range L to R. But what I want to explain here is, instead of thinking in the simple format, if I had to do it, use like the approach that I was applying was n log n, although that approach was not getting accepted for some weird reason, but it should have got accepted, I think. Okay, but for many people it was not getting accepted for some reason. So what I want to say here, guys, is that if suppose that normally the problem is taking n square time, what if I think in the reverse format? Okay, if I had to think in the reverse format, so what would I do? Okay, I'm explaining what concept I thought about. So what I would have thought is, like I would have thought that, suppose that the array is having all the elements as 0. Okay, initially I would have thought about this, and then my result would also have been 0. Okay, so this I would have put in my answer. Okay, that currently the result is 0, so I would have put this thing in. Okay, initially I would have thought every element like this. Then after that I would have iterated in the BRR array from the back side. Okay, inside, like, if from here it is removal, right? From left to right, they are saying that they are removing the element. So after removing everything would have been 0. Now after removing everything, it would have been 0. So if you see from this side and try to add, okay, from left to right, they were saying that you have to remove. Okay, from left to right, they were saying that they are removing. Okay, so I'm saying that if you move from right to left, then you will be adding. Is that clear? Please write yes in the chat. Are you getting my point? What I'm trying to think here, very very interesting. Okay, are you getting my point here, guys? Kindly tell me. So what I'm saying here is, if from here to here you were removing the elements from the ARR array, so assume that the ARR array was 0 after removal. Okay, so that then result would be 0. Update that result, whatever is the result at the starting of the this update. Then iterate from the backside and try to add, guys. So when you are at this, guys, so at the index 1, like basically you have to add the index 1 element. So what will you add? At the index 1 inside the array, what do you have? So you have 1 2 3 4. So at the index 1 you have the element as 2, so you will add it there. Okay, so this will become what? 2 0 0 0. Okay, then the result will become how much, guys? The result will become, after this you will update the result as 2, because if this element gets updated, okay, so see, if this element gets updated, guys, okay, if this element is getting updated, so if this element is getting updated, so I need to see that how many elements are there. Like, see, if this element is getting updated, okay, then on my right 0 is there. Okay, if this element is getting updated, so on the right of it 0 is there, so there is no impact. On the left there is nothing. Okay, on the left there exists no element, so only this element is getting updated, so subarray sum is only becoming 2. Okay, then after that what will happen is, after that, guys, what will happen is, when you will move to the element 3, okay, so then you will add the element at the index 3, so you will update 2 in your result as well. Then after that what will happen is, when you update the index 3 elements to 7, so then it will be like 2 0 7 and 0. So the moment you will insert 7 now, so then you will check on your left side. Okay, there is 0. Okay, on the right side also there is 0, so this element will not have much impact any on the answer, but this is 7, so now the maximum is this much, so result will become 7 now. Understanding my point, guys? Now what will happen here is, so now the result is 7 because maximum is 7, so you'll update this. Now after that what will happen is, so how you have to update, that is the main thing, how you will update your result every time. Okay, how you get your result manipulated based on the insertions every time. Okay, based on the update. So now at the last what will happen, like after this what will happen is, like you will have 2, then you will have 0, then you'll have 7, and then you will have the element so did I made some mistake? No, hopefully not. Yeah, so then I'll update the 8 also. Then the result would become how much? 15. Because on the because for 7, when I'll check on the left of it now, then there is 0. So on the left, nothing is getting added. Okay, no bridge is getting connected. But on the right, you can see that what is happening. On the right, I am getting this thing. On the right side, I do have an element, so this much I would add, so then my result would become what, I guess 15, so then I will update 15. Okay, and then after that, when you add one more element and all that, so this is what happens. So basically after all the queries, you can see this is the update. So basically, since you iterated in the reverse order, so you got the answer in the reverse order, then you will reverse again. Is this much part clear? Please write clear in the chat, and then I'll explain a bit more. Okay, is this much part clear? Then I'll explain a bit more why do we need a prefix array and things like that. Is that clear? Right. Makes sense, guys. Please write clear in the chat first of all. +1 in the chat. Hit the like button for acknowledgement purpose. Okay, and then I will explain the intuition. I'm not going to do a complete dry run because the dry run doesn't matter that much as the thought process matters. And a dry run will just write in dry run. I'll write a lot of things, but if I'll explain the intuition, that is more important. Clear, but what is the advantage? I'll tell you. See, what I'm saying here is suppose like what I'm saying here is like what you would try to kind of do is suppose these elements are there. Okay, so what I might try to do is suppose that you had 4 6 then 3. Okay, suppose these elements were there and then you had got, let's say, 0 0 0 here. Okay, suppose that you have got 0 here. Okay, then what you have is, let's say, 7 8 was there. Okay, then you have got 0 0 here. Okay, now suppose that you are going to update which element, you are going to add this element. Are you getting my point? Can you take one larger input? I have not thought about any larger input, and honestly, we don't have that large input, so that's why this test case is also not that big. It looks big, but it is not. So that's why I would suggest that we think about the logic more, Sachin. Okay, that is more important. Otherwise, you will get occupied in values a lot. Okay, what I'm saying here is, what I'm saying here is, what if I update this element? Okay, what if I update this element? Whatever element was here, if I update it, then what will be the maximum Savary sum? Can you tell me, guys? What if I update this element, then what would be the maximum Savary sum? Can you tell me? If I update this element, what, like, suppose this element was 5 10 20, whatever it was. If I update this element, then what would be the maximum Savary sum? From 4 till, like, from here till here, please write yes. Agree with me, everyone? From here till here, then the sum would be from here till here. Do you agree with me? Yes or no? Right, if I update this element, then this would become a contiguous subarray. Correct? Correct or not? Yes. Okay, suppose this was, I am talking about the ith update. Suppose this much was the array. After certain updates, this is how the array looked like. And then in the ith update, if I am going to do this, if I update this element, the moment I will update this element, so I'll update something that is non-zero here. The moment I will update something here, then from here till here, everything will become contiguous, and this is a contiguous subarray. Right? Now, how do I find? So now whatever is the sum of this whole contiguous range, that will be my sum now. So what I will do is, I will do a, like, what I will do is, now if you understand one thing, so somehow if I am able to get this left index, okay, and if I'm able to get this right index, okay, so then I can get the sum of this range by doing p of right minus p of left minus 1. Are you getting my point? I have to find my left and right. That is one thing. But how will prefix sum help? Because suppose if this element if this element gets updated, then this whole range will become contiguous. So then I will say that now the maximum sum would be of this much range. Okay. So if suppose that I had left and right, so if I had it right with some logic, we'll get it. I'll talk about that. But if I had it right, then the sum in this range would be nothing but p of r minus p of l minus 1. Please write +1 in the chat. Are you clear why prefix sum would be important? Because somehow if you know that this much is now the contiguous range, updated range, okay, so then the sum of that range would be p of r minus p of l minus 1. Agree? Yes or no, guys? Please tell me. Agree or disagree with me? Okay, Umang Soni is saying agree. Okay, what about Man is saying clear. What about others? Others are able to get this point? I am saying that suppose that you had 0 here in between. Okay, now you updated the 0 to whatever element you had. Then you want the sum of all the elements from here to here. Which algorithm can give you it very fast or in order of one time? Prefix sum. So suppose if I knew this left range and right index, leftmost and rightmost current index, then I would have got p of r minus p of l minus 1. Right. So what I would have done is, like, how would I have got it? Right. So basically for this, what I did was I used a set based approach. Okay. So what I did was I used a set based approach. What I did was I found what I did was I used a set to first of all find this particular index. Okay. Index of the element that is like what I did was I applied by by search inside set, and then after that, like once I got this as my index now, then after that I updated L to this particular place, and then like on the left, like basically what I did was whatever index I was at, I found the first index on the left side, that is 0. Okay, you find the first index on the left side, that is 0. Find the first index on the left side, that is 0, and find the first index on the right side, that is 0, and then whatever left you have found, you do left plus 1. Okay, so that you can stand at the non-zero guy, and whatever is the first guy on the right after the index, that is 0, you do one less than that, and then you point on the right here. Are you getting my point? Okay, guys. So whichever this place is, first index on the left, that is 0. Okay, plus 1 you do. Okay, then first index on the right, that is 0, you do minus 1, then you get to the non-zero guys, and then take the sum of that range. Is that clear? Please write yes in the chat. I hope this logical side of thing is clear. Yes or no? And for getting that, I was using a set based approach. If so far you are clear now, you can tell me. I will try to explore the DSU approach if possible, but first of all, let's discuss what I was trying to do. No? Actually, this approach should have got accepted, but it was giving TLE. But still, I will still suggest that you should go through this approach. I'll ask the team why they didn't allow n log n, but I think n log n should have got accepted. Okay, so you don't need to worry. Still, that is why I'm giving this code to you all. Okay, so yeah, let me just give it to you all. Okay, so yeah, logical part is clear. What I wanted that on the left side, like whatever is the first index of 0 plus 1, and then on the right side, whatever is the first index of 0 minus 1, I have to do, because I have to point at this 4 and 8 respectively. No, that's why. Okay, now if you will see here, what I did was, like, that is why I took a set, and that is why my approach took this much time. So see, what I'm doing is, I am first of all declaring a prefix array. Okay, and I also have an answer array. Now what I've done here is, I have initially marked my result as 0. Okay, because I'm doing in the reverse format. So remember that I had made the result as 0 here, somewhere here while I was explaining. So initially I had made the result as 0. Remember this. Okay, so that is the same thing that I'm applying. So DSU is still log. uh what kind of DSU is applied there? I have not seen any DSU solutions, or I did not think about DSU solutions honestly, so that is why I cannot predict. But I still want to tell you about my n log n approach. Okay, although this was giving a TLE, but still I feel that this is correct. So I'll talk with the team why it was giving TLE, but I feel that this is correct solution. Okay, so yeah, you can see here my approach is n log n. Okay, so you can see here what I'm doing here is I am taking the prefix sum. So prefix of I is equal to prefix of I minus 1 plus AR of I, the way that I've explained, and P of 0 is equal to A of 0, already I have explained. Then I am taking a set. Why I am taking a set? So initially I'm inserting all the indexes inside the set. Okay, it should have worked. Yeah, it should have worked. Ideally, it should have worked. So basically, that is why I'm still explaining this now, because I believe in my solution. Okay, so the thing is that what I am doing is, initially I'm inserting all the indexes inside my set. Okay, and how will I get the index of 0? Understand one thing. Why am I using the set here? Okay, because suppose that if you had got these things, okay, then you had got what, 2, then 8, then 4, and then 0, and then 5, 7, 0, 0, something of this kind. Okay, so what I will do is, inside the set I will store the indexes. Okay, see, if I am at this index, let's say this is what, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's say this element was what, let's say this element was 13, let's say 17. Okay, now when I'm at this particular index, now what is this index, guys? This index is basically, suppose 6 index. Okay, now why am I using a set? Because inside the set, see, if I am going to update now, so inside the set I will consist of all the indexes that are not yet updated. Okay, so 0, 1, 2 is not updated, 6 was not updated, 9, 10, 11 is not updated. Okay, these are the indexes that are not updated. Okay, now what I will do is, whenever I come to this index 6, so I will say that now I am going to update the index 6. So first of all, I'll delete it from my set. Okay, so you will delete this index, like you will find this element 6 and you will delete it from the set. Okay, first of all, you will do what, you will delete it from the set. Okay, now what you will do is, inside this you will find the first element, which is the first element that is greater than 6 inside this set. Can you tell me which is the first element that is greater than 6 in this particular set? Can you tell me, guys, which is the first element that is greater than 6? Can you tell me this particular element? No, 9 is the first element that is greater than 6. Okay, so my level pointer will point here. right? My lower point, like my pointer will point here. Let's say left L pointer, whatever you want to name it as. Okay, then when I'll do LV minus minus, because if the left exists, okay, then I have to move here. So my LV will now point here, because like I will find the index of the element that is just greater than 6. Okay, and then I'll do minus minus for that index, and then I'll get to this index 2, which indicates about this index. Once I got this index, then my left index would be what? Left index would be nothing but LV plus 1, na? LV index plus 1. Are you clear with this, guys? Please write yes in the chat. Are you clear with this? What am I doing in my code, at least? Yes or no? Please tell me. Does that make sense? Yes or no, guys? Everyone, please write +1 if you're clear. What I'll do is I'll apply by search, that is a lower bound function. So in log n time, I will try to search which is the index that is greater than 6, and then I will find that my pointer will point at the element 9, and then LV will point at 9. And if it is not the first element of the set, then I will do minus minus, and then LV will point at the element index 2. So once it points at the index 2, so my left would be nothing but LV plus 1. That is this particular guy. Right? Clear, guys? Right? Now same goes for the right. What will happen for the right? Understand this thing. Okay, so what you will be doing here is now, so suppose that this is done now, like after that, once you want to find for the right, so inside the set, what all data you have got 1, then you have got 0, then you have got 1, okay, then you have got 2, okay, then what you have got, 9, 10 and 11. Okay, this is what you have got here. So now if you have got, let's say something like what was I updating? Yes, 6, right? So yeah, if you have got 6, then what was I doing in my code? Let me just check. So upper bound I was finding now. So yeah, upper bound I was finding. So index of the element that is greater than this. Yeah. So basically, then what will happen is that then what will happen here is, suppose if I'm here, right? So yeah, like what I will do is on the same way, I will find the up and then upper bound. So upper bound will give me the index of the element that is greater, na? Let me just check. Let me just check in terms of definition, because I'm getting confused. Upper bound inset. Okay. So what does upper bound give me? It gives me the returns points to the next element in the set container. Okay, it will point to the next element. Okay, so yeah, it will point to the next element that is greater than this element. So it will basically point where, somewhere here, I guess, right? Yeah, okay, yeah. So like in my upper, what I want, I up will be pointing here because I want the index of the element that is greater than this guy. Okay, so obviously I'm going to update it, but yeah, it will point here. Now once I get this, then I have to do -1. So my right would be what? Right would be up -1 if the up is not at the starting. So it would be up -1. Are you clear with this part, guys? Yes or no? Yeah, strictly greater than 6, so that would be the index 9. So here okay, then when I'll so it will give me this particular index. Once it gives me this particular index, then I'll do minus minus, so it will allow me to point my right here at this point. Now it up will stand here, so when you do up -1, you will be able to stand here at the right. Yeah, it should have not given a TLE. That is what I'm trying to say, na guys. Is that clear with this part, guys? How I'm using set? So that is what I'm doing, and then in that range I'm finding the sum. That's it. So you can see here what I'm doing here is right. So you can see what I've done here is I have declared my prefix sum, then I'm declaring result as 0, then prefix of 0 is equal to a of 0, then I'm declaring my set. I'm initially inserting all the indexes inside the set, and once I keep on processing all those indexes, I'm removing that from my set. Okay, and why I'm taking prefix sum? Because at the end I want to get that sum from the left range to the right range very fast. So that is why I'm doing p of right minus p of left -1. Okay, that is what I'll be doing, and I'm iterating in the backside because I'm thinking of adding the element. So initially I will do what? In my answer I will push the result, okay, which is obviously 0. Then the index would be what? Like BRR of I is the index, okay, is that element, and since it is 1 base, so I will do -1. Okay, that is the current index that I want to process. And if I want to process it, so I will do what? I will delete that index from the set, and then after that I will check that if my set size is greater than 0, so if my set has got element, then only I can apply the lower bound and upper bound function. No, then only I can check for the LV and UP that I've explained. Okay, because if I want to search, so there should be at least one element inside the set. So I will search for my LV and UP, and my left would be what? If my LV is, if I'm searching for it and it is not standing at the beginning, right? Then I will do minus minus for it. Okay, and then my up will be what? It will be this guy plus one, like LV plus one, as I've already explained. Otherwise, if it does not exist, then my left would stand at 0 only. Okay, so if it does not exist, so if there is no, if this is, suppose this is the first element only, and on the left it does not have anything, then the left would be 0 only. Okay, and suppose you are checking for a particular element, you are checking on the right side. So if you're checking on the right side, so you find the up and then you do minus one for it. Okay, you just find the up and do minus one for it. Okay, because that is what I was explaining. And if suppose that it's not present, so then you point your right to the last element. Okay, then after that what you do is simple. You take the prefix sum. So if the left is greater than 0, then you know that the prefix sum would be, then the sum of that range would be right minus prefix of right minus prefix of left. Otherwise the sum would be prefix of right only. Okay, if the left is 0, and like result, you will update the result as the maximum because you wanted the maximum, and every answer will get pushed, and at the end you have to reverse your answer because it is stored in the reverse order. So just simply return. So I had done it in n log n. I didn't know why it didn't get accepted. I'll raise this issue with the team, but it should have got accepted. Is this clear? Please write clear in the chat. Are you crystal clear with this approach, at least with the approach part, guys? Okay, I hope that you are clear with this approach. Okay, so this was my approach, and I believe you should stick with it. It teaches you a lot. Clear? Please write clear and hit the like button, guys, if you're clear throughout. Now you have to promise me one thing, that after this video, so see, I have done it like my approach is n log n. Okay, but for some reason it is showing TLE. I'll talk with the team why that is so, but it should have not given a TLE given the constraint. So I'll talk with the team why that is so. Okay, but I still stick with this particular approach. Okay, so don't comment later on that my approach is giving TLE. I know that it is giving TLE, but it should not give TLE because I'm using set only, so it should have been n log n, but for some reason it is still giving. So no worries for that. We'll talk with the team regarding this. Okay, that is there some issue with test case or something? Okay, I'll talk with them. And if you have understood this, did you enjoy this session throughout? Okay, did you enjoy this? If you enjoyed this, if you learned something out of this session, okay, so please make sure, see, if I do something good, nobody is going to comment. That is what happens, right? If you do something good, nobody is going to comment. If you do something bad, then people are going to blame you, people are going to criticize you in chat and whatever. So if you feel that I've done some if I was worth your time, right? If I was able to, can you explain n log n time? Why? Because obviously, yeah, I'm using set, na? So I'm using set. So set insertion and deletion takes log n time, na? Like in set, lower bound, upper bound, all these functions takes log n time. So it will be n log n in the worst case. So that is why. Okay, basic. Now see, if you enjoyed this, if you learned this, so please make sure to comment understood after this video is over. No, after this video is over, then no, it will come as a normal video. So after this live is over, so make sure to comment understood. Make sure to tell me what you liked, if you enjoyed this session, if you enjoyed the energy throughout. Okay, and yeah, that is what I believe that you should do, and try to be consistent, guys. Okay, did you enjoy this session overall? Like, did you learn something plus one? I hope that you did learn something out of it, and I'm wishing you a happy Holi, guys, right? I think tomorrow you have full Holi, right? So uh, come like buddy Holi or something like that. So whatever it is, understood, appreciate your approach. Yeah, thanks a lot. So that's why instead of dry running, na, I was focusing more on the logical side, because if you know what logic you want, then you can search what functions you want to apply and then apply them. That's at sir your LinkedIn again. Actually, if you will just search this thing, so if you want, I'll share it. Okay. You can connect. And if you enjoyed this, you can do one thing. You can if you enjoyed this discussion right so far, then you can take a screenshot. First of all, take a screenshot of this if you want. Okay, so just give me a second. I will do something like this for you. Okay, yeah, first of all, I'm showing this screen. If you want to tag me on LinkedIn, suppose, and Sandeep sir also, right? So first of all, take a screenshot. I'm giving you 1 or 2 seconds. Okay. So once you have taken the screenshot, so what you can do is, I hope that you all have taken the screenshot here, guys. Done. Please write. Please leave an arrow here if you're done with this screenshot. Okay. So yeah, what you can do is, if you have taken the screenshot, you can take the screenshot from in between somewhere. Okay. Then after that, what you can do is, you can on LinkedIn, you can write a post. Okay, where you can tag me. I have given my ID, and you can tag Sandeep Jan sir. Okay, and you can tag GeeksforGeeks also. GeeksforGeeks account also you can tag, and there you can share that yes, you have solved this many problems in the contest. Sandeep sir will also see it, and others will also see it. They'll feel happy about it. Okay, entire GFG team will feel happy about it. Okay, so that is it for today. Thank you guys. Thank you for joining, and I hope that you enjoyed this particular discussion. Till then, bye bye. Take care. See you, and Shabba khair. Take care. Bye, guys. I'll see you next week, maybe. Thank you. Keep coding. GFG कर लो, हो जाएगा. And make sure to comment.